To the next topic discusses about absolute values. The following are the learning outcomes. Okay, we start with the following situation. Ali is at the origin. So where is the origin? This one we consider as the origin. Okay, denoted like this, origin. Consider the following two cases. If Ali walks 4 steps to the right, okay, moves to the right 4 steps, what is his current distance from the origin? You can omit the here. Okay, all right, so what is his current distance from the origin? The second case, if he walks 4 steps to the left, to the other side, okay, what is his current distance from the origin? Okay, what is the answer for these questions? So we consider the following. Okay, we can represent the previous case mathematically, right, like this. Okay, we draw the line. So we start from the origin. So the origin is represented by 0, 0. Okay. So if he moves from origin to right, okay, 4 steps. So that means this is the location. The location is at Q. Okay, so the distance is 4 steps. The unit is steps, right? So we have 4 steps. Similarly, if he moves to left side, so he arrives at P after 4 steps. So the distance also, what is the distance? The distance also 4 steps, even though he is at the negative side. Okay, negative 4 here. Okay, the same distance, whether he goes to right or left, he has the same distance, okay, which is 4. Thus we write the distance in the following form. Okay, we enclose the value by using this straight horizontal line. So we have the case of absolute value. The absolute value of negative 4 equal to 4. The absolute value of 4 also equal to 4. So we use absolute value actually to represent the magnitude or the distance, which is always positive. Okay, this is the definition for the absolute value. Absolute value can be written as like this, enclosed in 2 vertical lines. Okay, and it is defined as follows. Okay, so the absolute value of x, we enclose x between 2 vertical lines. It is equal to x if x is greater than or equal to 0. Okay, for example, okay, if we take one value, let's say x is equal to 1. So the absolute value of x is equal to absolute value of 1. Okay, so based on the definition, because x is greater than 0, so it is equal to x equal to 1. Okay, so the value for the absolute value of x equal to negative x is if x is less than 0. So for example, if x equal to negative 1, because negative 1 is less than 0, right? So the absolute value of x, it is absolute value of negative 1. It is equal to negative x. Negative, we put x inside the parenthesis, negative 1. Again, it is equal to 1. Okay, can you see the difference? So we need to maintain the negative sign, and then we enclose the value inside the parenthesis. Again, we have a positive value 1. Okay, so we have the following properties for absolute values. So the absolute values of a is always greater than or equal to 0. Okay, you can consider the example as well. So the absolute value of a equal to the absolute value of negative a, as I shown in the previous example. Okay, so the absolute value of a plus b is equal to absolute value of b plus a. That means the absolute value is commutative. We can replace the position, change the position of a and b, then we still get the same answer or the same value. And then for the subtraction also, we have a minus b equal to b minus a, got the same value. For the multiplication, okay, so if we multiply a and b together and then we put the absolute value sign, it is equal to, we multiply the absolute of a with the absolute of b, still get the same value. For the division as well, we can the value for the absolute a over b is equal to the value of absolute a divided by absolute b, provided that b not equal to 0. Okay, as you can see here, still come out with the same value. Okay, quotient, remember that, okay, the absolute of a plus b not equal to absolute a plus absolute b. Same goes with the subtraction. A minus b not equal to absolute a minus absolute b. Sorry. Okay, remember. Okay, so how to solve equation of absolute value. We start with equation, later on we cover the inequality. Okay, solving equation of absolute value, we have two methods. We have basic definition method and we also have square both side method. Okay, solve the following equation. So we have a equation with absolute value. Okay, so we have the absolute value of x equal to 4. We want to find the value of x in order to solve the given equation. So using two methods. The first method is basic definition method. So we can use the definition of absolute value. So absolute value of x equal to 4 means that x is equal to 4 or x equal to negative 4. Okay, because if we replace x, okay, absolute value of x, okay, if x is greater than or equal to 0, it is equal to x. So our x is equal to 4. Okay, for x equal to negative 4, the absolute value of x is equal to negative 4. Again, we have 4. So we have two values, possible values for x, which are 4 and negative 4 based on the definition of absolute value. So that is what we call as basic definition method. Now we move to the second method, which is the square both sides method. So from the given absolute value, we put square at both sides. Okay, so when we put square, so we can omit the absolute value sign because it is square, it is always positive. So the remaining expression is x square at the right hand side. So 4 square is equal to 16. So from here, it's very easy to solve for x. So x is square root 16, which give us two possible values, which are x equal to 4 and x equal to negative 4. Okay, the same question but different absolute value equation. So we have x plus 8 equal to 2. Our task is to find x. So by using the basic definition method, so we have two possible values for the x plus 8 equal to 2. So which is equal to x plus 8 equal to 2 and x plus 8 equal to negative 2. Okay, based on the definition of absolute value, we consider two possible values, 2 and positive 2 and negative 2. Now we solve for x, okay, because in both equations, the only unknown is the variable x. So it's very easy to solve for x. We have two values for x equal to negative 6 and x equal to negative 10, and we put in set form to give the final answer. So using the other method, which is the square both side method, so we can put square at both sides. So for the absolute value, again, once we put square, so it becomes the ordinary parenthesis. So we have this square sign at the right hand side, 2 square equal to 4. Okay, so if we put square root at both sides, okay, so the square the square value can be eliminated, so it becomes x plus 8, while at the right hand side it becomes plus minus 2, which is the square root of 4. So we have two equations to be solved. Here we have x plus 8 equal to 2, x plus 8 equal to negative 2, because the remaining unknown value is x here. So it's very easy to solve for x. We have two values for x equal to negative 6 and x equal to negative 10. Okay. Okay, so we covered the absolute value equation. Now we move to the absolute value inequalities. The following are the learning outcomes. We consider the following cases. For any positive real number A, okay, for any positive real number A, then the absolute value of x less than A is true when or if and only if x is greater than negative a and x is less than a, or when x is greater than negative a and x is less than a, then we have this becomes true. Okay, for the absolute value of x less than or equal to 0, it becomes true if and only if when x equal to negative a. Okay, why equal? Because we have this equal sign. Okay, and then the second situation, or when x is greater than or equal to negative a and when x is less than or equal to a. Okay, the third one, the absolute value of x is greater than a if and only if x is less than negative a or x is greater than a. Okay, and for the last one, we have x is greater than or equal to. We just simply add the equal sign to the inequality. Okay. Alright, so how to solve the absolute value inequalities? Also, we have two methods, just like the absolute value equation. We also can consider two methods. The first one is basic definition method, so based on the definition of absolute value. And the second one is square both side method. Okay, we start with first one. Solve the following inequality. We use the basic definition method. So because we can consider this one as x. Okay, just like in the previous slide, we consider it as x. So the x and this one as a. Okay, as a. So the absolute value of x less than a if and only if we have the following situation. Okay, when x is greater than negative a and when x is less than a. Okay, so now we replace back x with x as 2x plus 3. Okay, this one is 2x plus 3 and a we replace as 5. So we have negative 5 and 5. Now we have this inequality. From absolute value inequality, now it becomes the ordinary inequality, linear inequality. So now it's very easy for us to solve for the unknown x. Okay, so first of all, we want to eliminate 3. So that means we minus 3 at for the every item. We have minus 3, minus 3, minus 3. So we can eliminate these two values, becomes 0. So the remaining value is 2x greater than negative 8 and less than 2. And then we want to eliminate 2. So we multiply each item by half. So we come up with this range as the answer for the absolute value inequality. Okay. And for the second one, solve the following inequality again. So we have in this solution, we use the squaring both sides technique. So we put square at both sides, square and square. So because square, so we can omit this absolute value sign, so it becomes ordinary parenthesis sign. Okay, so this one got square. So for the right hand side, 2 square equal to 25. Okay, for the left hand side, we can expand 2x plus 3 as 2x plus 3 times 2x plus 3. So we come out with this expression. We take 25 to the other side, so it becomes negative 25. So we simplify this quadratic equation. So we come out with this equation because we have factor 4. So we can divide all items by 4. So come out with this simpler equation, simpler quadratic equation, x squared plus 3x minus 4 less than 0. So now our aim is to solve this quadratic inequality for the unknown x. Okay, previously it is absolute value inequality. Now it becomes quadratic inequality. So we solve for variable x. So we can factorize. It becomes x plus 4, x minus 1. Okay, remember we want to consider it is less than 0. Okay, so we have three options as well how to solve, but this time we choose the number line method. Okay, for the number line method, although the given situation is less than 0, but we need to consider the case when both are greater than 0, because our line is pointing towards positive infinity. So we have x plus 4 greater than 0, and we have x minus 1 greater than 0. We solve for x. We have x is greater than negative 4 and x is greater than 1. So we draw the number line. So we have two values here. It moves from negative 4 to positive infinity. We have this line. We move from 1 to positive infinity. We have this line. So the area without the area without lines considered as negative. Okay, so negative times negative is positive. We move to the middle side. So without line it is negative, with line it is positive. So negative times positive, it is negative. And we move to the right hand side. The area with a line we consider as positive, the area with line we consider as positive. So positive times positive, it is positive. So back to our original question. The question asks you to find the value less than 0. That means we need to consider negative area. So in this number line, so where is the negative area? The negative area is covered by the shaded area. So the shaded area is represented by the following range. It is x greater than negative 4 and x is less than 1 as the answer. Okay.